Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Algebra 1 Common Core Regents problem number 29. If you want to find these tests, they're freely available online. Go to nysedregents.org, click on the appropriate tabs, and all the tests are freely available to you. So here's the problem. Is the sum of 3 radical 2 and 4 radical 2 rational or irrational? Explain your answer. So many pitfalls in this question. For example, make sure you perform the operation asked sum. Make sure that you don't just guess. Make sure you don't just state an answer. Although stating an answer will give you points if you get the answer correct. If so, suppose you don't know how to do this. But pause the video, try to think about it on your own, and see if you get the same answer that we do. So here's our explanation, though. Look at this word explain. I will say this, explain is not the same as justify. Here's a very big hint. This says sum, this is a plus. So why not add them? And I know that 3x plus 4x equals 7x. I know 300 plus 400 is 700. I know 3,000 plus 4,000 equals 7,000. So 3 radical 2 plus 4 radical 2 equals 7 radical 2. Okay, now this is not rational. How do I know? Because radical 2 is irrational and 7 is rational. So the product of an irrational number and an irrational number is irrational. So the answer is that this is irrational. And so 3 radical 2 plus 4 radical 2 is irrational because, and this is a perfectly valid explanation, 7 radical 2 cannot be written as a fraction. Okay. And that's the full answer. So let me just do a quick review before we go on to the next problem, because there are some definitions that a lot of kids don't have, and that's why they can't do this. You do need to know this. A rational number is a number that can be written as a fraction. As a fraction. Let's say a over b, where a and b are integers. Okay, there's an equivalent definition. It's totally equivalent, and they are absolutely equivalent. They're the same definition. So a rational, and I give them both because there are situations which you need both. A rational number is a number that can be written as a repeating pattern decimal or a terminating decimal. Okay, so that's what you need to know. And then the counter definition, an irrational number is a number that cannot be written as a fraction, nor a repeating nor terminating decimal. So a number that cannot be written as a fraction, or nor terminating nor repeating pattern. Decimal. Okay. So some classic examples. So irrational. The radical 2, radical 7, radical n where n is not a perfect square. And here's a pattern. Here's a number with a pattern. And pi. Pi is also an example. When you learn what e is, hopefully you definitely have seen it before. E is around 2.718, but it is a irrational number. It's transcendental. And there's another example of a number that has a pattern: 0.1, 0.1, 0.0.1, 0.0.0.1, and then 0.0.0.0.1, and you could probably see the pattern: 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 6, 1, dot, dot, dot. Okay? Notice that this is a pattern, but it's irrational, and that's where we got to be very careful with the definition. Repeating or terminating decimal. Repeating pattern or terminating decimal. This is not a repeating pattern. It's a pattern, but it doesn't repeat. Repeating pattern would be an example like this, like 8.56, let's say, then 7.1, 7.1, 7.1, 7.1, 7.1. So the 7.1 repeats forever and ever. Okay, repeating decimals can be written with a bar over it, which means that that's the pattern that repeats. Also like 2/3, 5 halves, so that's an improper fraction. Also numbers and the integers like 8, which is equal to 8/1. That is a fraction, so can be written as a fraction. Didn't say is written as a fraction, but can be written as a fraction. Even 0 is equal to 0/1. So that's a rational number as well. Okay, so now we know our definitions, and let's go to an example over here. Is the sum of 2/3 and radical 2 rational or irrational? And explain your answer. This goes a little bit beyond what the previous problem was, so I suggest you pause the problem and think about this one. If you get this question right, then definitely hit the like button. Subscribe if you think these videos are helpful. So 2/3 and radical 2 is the sum, rational or irrational? So the question is, can this be written as a fraction? There is a proof that this is irrational. So if 2/3, so radical 2 is irrational. So if 2/3 plus radical 2 is rational, then 2/3 plus radical 2 equals p over q. Subtract the 2/3, and you get radical 2 is equal to p over q minus 2/3. But this is rational, and this is irrational. So this is impossible. Okay, so here's a perfectly justifiable explanation on the test. You don't have to give the proof. That's a proof, and you could use words. But you could also say you could say 2/3 plus radical 2 is irrational because the sum of a rational and a rational number and an irrational number is irrational. Okay, so if you're the kind of person who likes to memorize rules, here's some rules. Let R be a rational number. No, let me not do it that way. Let me do it this way. Rational plus rational equals is rational. Okay? Then if they're both irrational, irrational plus irrational. Now, don't say irrational, because that's a very big temptation. Could be either. It could be either. For example, radical 2 plus negative radical 2 is 0, which is rational. But radical 2 plus radical 3 is some other radical. It's irrational. So irrational plus irrational could be either. But if you have one of one and one of the other, so rational plus irrational, well, that's irrational. Cool. And what about the products? Okay. Let's assume we're not multiplying by 0, so not multiplying by 0 by 0, not multiplying by 0, and also not dividing by 0. So I'm going to change this to plus or minus, plus or minus, plus or minus, because it could be either one. So the other rule is then that if you multiply a rational number and a rational number, well, the product is rational. I highly recommend, what did I just do? I'm sorry, this is a multiplication. There we go. And then the other case, if they're both irrational, well, actually it comes out just like the other case, the addition case. This is actually either. For example, radical 2 times radical 2 is 2, which is rational. Radical 2 times radical 8 is radical 16, which is 4, which is rational. That reminds me, if I can go back a page, there's one that I wanted to give on this case of a rational number. I'm sorry. Sorry, a rational number. Don't forget that radical, just because it's a radical doesn't mean that it's not rational. For example, radical 25, this is equal to 5, which is equal to 5 over 1. So radical 25 is rational. Irrational examples are the square roots of numbers that are not perfect squares, and also other numbers. So, but if the number is a perfect square, then the radical of that number is rational. So an irrational number times an irrational number could be either. Rational times rational is rational, and then of course a rational number times an irrational number, so one or the other, is irrational. So the addition rules, the subtraction rules, the multiplication rules, the division rules, they're all the same. A rational number plus, minus, times, or divide a rational number is rational. An irrational number plus, minus, times, or divide a rational number could be either, depending on the case. It's unknown. But a rational number plus, minus, times, or divide an irrational number is definitely irrational. Hopefully the lesson that we just learned is helped you, supplemented what you need. Now this is enough to do almost every question on the Regents for when they ask for for whether things are rational or irrational. So hopefully that helped. Thanks for watching. Stay tuned for the next videos.